notebooks. We are finishing this up today. So let's share the screen. Get my Active Inspire up and going. Sorry, you don't need to see any of that. All right. So this is all the stuff we did yesterday, and here is our next one. So graphing and writing equations for quadratics. Today's lesson really shouldn't take us more than about 20 to 30 minutes. So we talked about this yesterday, but I didn't want that to be the focus. This is going to be our focus today. How do we use that A value to graph? Maybe you want to write this down. Maybe you want to take a picture of it. Maybe you just want to read through it and make sure it makes sense. So we're going to start by graphing our vertex. Then we're going to consider how many horizontal steps we are taking from the vertex and square it. So horizontal is left to right. Once we have that value, we multiply it by whatever A is. And that's going to be our vertical change. So again, we should see this all as information. I just gave us 3 to practice. We can do more if you guys want to see more. So down here in green, I'll change it to green. What is my vertex for this one? Can somebody unmute and tell me what's my vertex for A?
Two, 0.
Perfect. So my vertex is at the point 2, 0. So 2, 0 is my vertex. Awesome. Now, we're going to take more formal notes on this on Monday and next week, but remember, there's an axis of symmetry there, which means I keep talking about these horizontal steps, so I didn't say left or right, because if I take a horizontal step right or left, the y value will end up being the same. So if I take one horizontal step, and I'm just going to call it, you do not have to make a table like this. Here's my horizontal steps. So if I take one horizontal step, I want to square it, which is 1. And then I multiply that by whatever my A value is, and that is my vertical step. Now, I don't know how to explain that more clearly other than just keep showing examples. So horizontals left and right. So if I take one step right, I square that, then I multiply by my A value. Well, 1 times, what's my A value again?
1.
1. So that means if I go over 1, I go up 1. And remember, I said horizontal step, and you have to go both ways. So what if I take 2 horizontal steps? Then I square it, and 2 squared is 4. And again, I multiply that by my A value, and my vertical step is 4. So from the vertex, if I go over 2, I have to go up 1, 2, 3, 4. Over 1, 2, up 1, 2, 3, 4. Now let's just for good measure, if I take 3 steps, well, what's my vertical step then? 3 horizontal steps means what for a vertical step?
9.
That's it. So if I go 3, again, from the vertex, 1, 2, 3, I go up 9. So 1, 2, 3. And make sure when you guys are drawing your parabolas, that it is curved, it is not a V. And that's it. So let's put it together with what we did yesterday. What kind of a transformation is this? It is shifted what?
2 units to the right.
2 units to the right, and that's it. Okay? Now let's try number 2. Let's see what happens when we actually have an A value other than 1. So I'll do this in red. So I'm going to do H steps. I'm going to do our A value. So A is -2, and then vertical steps. So horizontal steps, we'll do 1, 2, and 3. Let's go ahead and start. What is my vertex on B here?
-3, 3, 4.
-3, 1, 2, 3, positive 1, 2, 3, 4. That's my vertex. Any questions about the vertex? Remember, it's always the opposite of what's happening to X. That's your H value, and this is your K value. So -3, positive 4. My A value is -2. So I'm going to kind of put this together. If I take one step here, I have to square it. So 1 squared times -2 means how many vertical steps did I actually take? Or, yeah.
-2.
-2. So again, here's your axis of symmetry, which we're really going to focus on starting next week. There's your axis of symmetry. So if I take 1 horizontal step, I go down 2. Does anybody have any questions about how that works? So what if I take 2 horizontal steps from the vertex?
Yeah, it would be 8.
It'd be what?
8. -8.
-8. There you go. So if I take 2 steps, I go down 1, 2, 3, 4, 5, 6, 7, 8. Then 2 steps. Again, that's kind of why when I graph, I like to put this axis of symmetry line down here so I know that my Y values are the same and I have to be 2 steps from the axis of symmetry. So if I took 3 steps, what's it going to be?
-18.
Perfect. So again, 3 steps, -18, that's going to be way down here, so on and so forth. There you go. Anytime you graph, I need to see 5 points, always. All right, let's clear this out. Let's change it to the blue, and now let's see. Oh, by the way, how would I describe this transformation? What's happened? It's moved, or it's been what?
Reflected over the x-axis.
Good. It's been reflected over the X, and what's the 2 do?
It opens down.
It opens down, but what's the 2 do? Does it stretch it or shrink it?
Stretches it.
Stretches it. So it's been reflected, it's been stretched, and it's been moved what?
3 units to the left and up 4.
Perfect. Okay. So notice I start with 1, 2, and 3, but we might not want to use those horizontal steps. What, by the way, why do you think I might not want to use 1, 2, and 3 horizontal steps? Anybody have any idea why I might not want to use these every single time, 1, 2, and 3, especially if I have a fraction?
Because then it could be like messy numbers. So you could use like multiples of 1/3, like 3, 6, and 9.
Perfect. So what she just said is we'd end up with messy numbers, and we're trying to graph here and make it to where we can see what those values actually are. If I use 1, 1 squared is 1 times my a value is 1/3. I don't want to take 1/3 of a step. I can, but it's going to be really close together and it's going to be hard to see. So try and use values, multiples of the denominator. So I'm just going to use 2 here. So 3 and 6. My a value is 1/3. By the way, what's my vertex for C?
1, -2.
1, -2. I want you guys to see if you can do this on your own. So if I take 3 horizontal steps, how many vertical steps am I really going to take? If I took 6 horizontal steps, how many vertical steps am I going to take? Take about 30 seconds and see if you can figure it out. Okay, so who can tell me if I took 3 horizontal steps, how many vertical steps did I have to take?
3.
3. So 3 squared is 9 times your a value. 9 times 1/3 is 3. So with that said, if I take 6 horizontal steps, how many vertical steps do I have to take?
12.
12. So if I go 1, 2, 3, I have to go 1, 2, 3. Again, 1, 2, 3. If I took 6, 1, 2, 3, 4, 5, 6, then I have to go 12. And that's what that's going to look like. All right. And again, you guys can see it is a vertical shrink or a compression because it's going to get wider. That 1/3 means my values are going to actually end up being smaller. And it's moved right 1, down 2. Any questions on that? So you will rarely, if ever, see me graph these making a table. You just don't need to do that if you know the rules. Now, let's see if we can apply those rules and write the equation given the graph. There's 2 really good ways to do this. But if you know what the vertex is, you also know how to find what your a value is. So I'm going to help walk you through this first one and see if you guys can discover how to find the a value. So here's the first thing. Number 1, I know that my vertex is 1, 2, 3, 4. It looks like my vertex is at 4, -3. Any questions on that? So because it opens up and down, again, this is details that we'll get to like next Friday. Because it opens up and down, I know its y is going to be whatever this a value is. What should be here and here, by the way?
-4 and -3.
Good. So any questions about that? That part's easy so far. Now we just have to find the a value, right? I need you guys all with me here. It's going to be a short lesson. We've only got 1 more page after this. And you guys are ready to go, and you should be able to do your entire assignment. So any questions about this so far? Well, now we need to find our A value. Go up again from your vertex. This is the axis of symmetry, right? So if I take one step over, I'd have to square it. So we can kind of do this backwards. So we've got horizontal steps, we have our A value, and we have our vertical steps. Well, remember, it's going to be these number of steps squared. So the first one, it was over 1 squared. So 1 times what equals, well, how many vertical steps did it go up?
3.
3. So I went up 3 steps. So what's my A value? 1 times A equals 3. So what's my A value?
3.
It's just 3. So some of this is going to be very simple. Some of this you're going to have to do some math. By the way, let's check and see if that really worked. So if I took 2 horizontal steps, 2 squared is 4. 4 times 3 should equal 12. Did it go up 12 if I took 2? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It did. That's how you check it. So it's the same math, you're just doing it backwards. Any questions? It's pretty easy if your A value is 1 or if it's a stretch. You're gonna have to do some math if it's a shrink. So I want you guys to take about a minute and see if you can do the second one on your own. Okay. So again, let's do this one step at a time. I know it's going to be y equals, we're looking for our A value, but what goes in the parentheses here?
X plus 1.
Now again, it's a parabola, so it has to be the quantity of x plus 1 squared. When you guys write that, people forget it. And then is it going to be plus or minus 7 out here?
Plus.
Plus 7.
Yeah. Now, all we have to do is look at the graph. If you guys can keep this straight, and you might need to go through and watch this again, you might need a little more practice. Horizontal steps, when you square it, times your A val equals the vertical steps. So here's my axis of symmetry, right? So how many horizontal steps did I get to take this one right here?
3.
3. So if I took 3 horizontal steps, when I square it, I get 9 times A equals, and how many vertical steps did I take?
3.
So 1, 2, 3. So what's my A value gonna be?
1/3.
That's it. And you guys said you'd never use algebra.
Shouldn't it be negative 1/3?
Oh, why is it negative 1/3?
Because it opens down.
Because it opens down. That's awesome. And that was going to be the last point that I was going to make. So how many steps did it make? It went down 3. So when it's vertical steps, if it opens up, it has to be positive. If it opens down, it has to be negative. Now, I don't care when you guys account for it, but it should be how many vertical steps. If you go down, your vertical steps should be -3. Either way, what makes something open down? When your A value is negative. What makes it open up? When your A value is positive. Any questions? And that was exactly, that's a great catch. Any questions? So that's why, again, I kind of introduced the A value yesterday, but I wanted to spend almost the whole period today talking about this stuff right here. It is a simple equation, but it's kind of funny because as soon as I go away, people are like, wait a minute, we do what? Happens every year. Last thing we are doing. Now, I copied these straight from the book. Now, there's a couple things I want to talk about because this is all you have to know. Your book is going to talk about horizontal stretches and horizontal shrinks and a reflection across the y-axis. That is not a standard. We're not going to talk about that stuff. Now, same thing, if it starts with a reflection across the y-axis, you don't even have to account for it. So I hope that you guys are kind of watching right here. But remember, the parent function of this is y equals x squared, which is going to look like this. If I reflect it across the y-axis first, then all that's saying is this point 1 and this point 2 would switch spots. Well, because that's your axis of symmetry, nothing changes. Now, if you guys know how to graph, you know how to use these, you already know everything about it, and that's part of the reason we're not going into so much detail about the horizontal shrinks and stretches. So you already know everything, so we don't need to yeah, it's too much for you guys to remember. But we are going to talk about the vertical stretches and shrinks. Do it in order. So it's going to tell you your parent function is this. So it's going to start by either saying a reflection or whatever, or a stretch or a shrink. And that's always with this. You just do what it says in the order it says it. So if I'm trying to translate that or write a rule for G, by the way, write a rule for G, that just means G of X equals. Well, if I want a vertical shrink by a factor of 1/4, by the way, and I know it's going to look something like this. What's my A value here going to be?
1/4.
Yeah, and this is real simple, 1/4. So it's followed by a translation 2 units right. So what goes in the parentheses?
-2.
X minus 2.
And then 1 unit up is just +1. Now let's look at number 2. Again, I want a rule for G, so here's your rule for G. It's a vertical stretch by a factor of 3 reflected across the x-axis, which means what's my A value?
3.
But it's reflected.
3, negative 3.
-3.
-3, again, because it's reflected across the x-axis, which means now all of a sudden these points are opening down. And it says, followed by a translation 1 unit left. So does that go in the parentheses or outside the parentheses?
Inside.
In the parentheses. parentheses.
Good, because what goes with the x? X moves it left and right. So is it going to be +1 or -1?
+1.
There you go.
Plus-
Now, if you wrote +0, it shouldn't be wrong, but you don't ever need to write +0. And it's not going up or down at all. All right. Again, on your homework, I know it might say something like a horizontal, a reflection over the y-axis. I got rid of the horizontal stretches and shrinks. That's all you're going to have to do, okay? Now, we are finished with class. If anybody is still struggling with big ideas or any of the log-on, I heard from a couple of you guys. If anybody is still struggling, stay on, and we're going to work this out right now. All right, so you have a big ideas assignment. It's the same one from yesterday. So go ahead, get that done. It is due by midnight on Monday, but do not wait till Monday night. All right, I will have office hours Monday right after school from 2:45 to 3:15 if you're struggling. All right, get this done so that if you are struggling, we can address it in class. And if you're still struggling, then we can do it in the help session. All right, other than that, you guys have a fantastic weekend. You've been a wonderful audience. You guys are doing a great job. Keep working hard. See you guys.